So what are we going to talk about today? It's basically three things. The first is that I will give you an introduction to basically what is the Open Subsurface Data Universe, the what's, why, how, who, and when. Answer those things, and then try to touch upon things we have learned, insights we have achieved, and finally wrap it up with some sort of, okay, what are the implications from this, or could the implications be with respect to how we think about the microservices or service design when we have such data platform in place. So the Open Subsurface Data Universe was basically created during the summer last year, and given that what we have achieved in a year's time frame is I'm quite impressed. So it was started by these companies. The 8, what we say, the leading members was basically the founders of it, and then since its foundation, of course, the other one has joined, and this is basically the operators, oil companies. And in addition, we have a lot of vendors, most importantly Amazon and Microsoft, because it's they who are really who is building this thing. We are specifying it, and they are building it and provides it as part of their services. That's the thinking. And that's also why we find companies like Google, they have been invited, but have chosen to take a little bit more backseat position as it is today. So at least there is a community, and it's built around the use of the open group as a standardizations body. So we do two things. We do a standard, and we do basically the implementation or a reference implementation of that standard using the cloud platforms out there. So the ambition is to basically to have to put data at the center and have subsurface and wells data stored in one single data platform. But that single data platform need also to basically to have multiple instances, and and we need to basically support both, say, high performance computing workflows and data, say, machine learning workflows, etc. And we cover all types of data, and so it's quite ambitious. And the key thing is to get in place a set of APIs that standardizes the access. So that's ambition one. That's the other part we talk about is that the term data gravity. That data gravitates data is more or less it's a fact of life. It's easier to add a new table to an existing database than spin up a new database. I think it's there, and of course the more data you have access to, the more value you can get from the data you already have. That's also some of these facts. And of course the data gravity is, say, create some beasts of data stores. And what we discovered when we took 40 of our own subsurface databases and moved the data to the cloud into a data lake, we were suddenly able to use the data in a much more flexible way. So we see that moving, or that the cloud really liberates data and can help us boost innovation in using that data. And of course, what are we struggling with? We see that we have a lot of what we call integrated applications where there is a very tight coupling between data and business logic. And of course, the database that might start out small grows into something that ends up to being unmanageable. And we see that the identity is broken, lineage is broken, and it's extremely difficult to use data outside its original context. And of course, in the end, repair and integration cost kills any kind of innovation. And that was something that all the oil companies discovered. We have trillions of petabytes of data, but our ability to use them to create value from them is limited. So that was the background scene. And then, of course, what we also see is that we enable, by separating data from data and data management from applications, we basically enable a new type of application. And where basically the ambition is, of course, to take advantage of the latest and greatest in technology. Microservices, use Kubernetes, web-based interfaces, support of machine learning where applicable, use of virtual reality, augmented reality where applicable, and basically get on to modernize the industry in many ways. And so what's in scope? The thing is that what the OSDU focuses about is the data platform services, the ingestion service, basically how to get data into it, to manage the lineage, and the APIs. And that is then standardized by the open group. So it will be a standard, and we will also provide the certification and test sets that makes it possible for, say, implementers of the OSDU standard to basically certify and say, okay, yes, we comply to the standard. And there will, of course, be the standard will evolve over time as well. That's and the application space, that's not been part of what we have, we address with the standard, but we see that there is maybe room for talking about how to do that stuff as well. But not that as part of the data platform, but as industrial joint ventures. The claim is that probably 80% of what's in there is more or less the same thing. No competitive advantage. And then, of course, we wanted that when we do the standardization, that it's based on public cloud and that we get the support from the cloud providers to basically build it, because they know how to tweak the technology. We don't. So we think it's better that Microsoft and Amazon and Google tweak the technology they own and operate to get the speeds and things we need. So, and the timeline we have around OSDU is basically we started out, technically speaking, say a year ago, but with the technical stuff, the work group started in Q4, and then we have the first demos now in June on then Amazon and on Microsoft. And then we started out with one data type, and we will add additional data types for the fall and try to go as fast as we can. So that's basically the picture of the OSDU as a community, industrial-led community, where we think that we can be able to accelerate our own innovation and get better control and get more value out of our data. So then to the discoveries we made. And the name of it is basically the master data repository pattern. But some definitions first. Of course, what is master data? Of course, it's the data that defines our industry. And for those who have been familiar or are familiar with domain-driven design, there is a very, at least resemblance between a master data object and an entity as it's defined in domain-driven design. Same with reference data, basically that which very often refers to as can be implemented as value objects. And of course, metadata, data about data, can be naming of functions or variables. But what we also have seen is that there is a sort of mismatch between the language of people doing data management and people doing software engineering. And we are working hard to bridge those gaps, but at least this is a small step. And give you an example of basically one of the main master data objects in the oil industry, a well, and in addition we can also add reservoir, but I focused on well. And there is tons of data that is attached to a well, from its position, how it's sectioned, going from say wide diameter down until you are down on just a handful of inches. You have the trajectories, completions, designs, production volumes. It's enormous amount of data, and of course, as it's been more or less impossible to know from going from database to database. Okay, is this the same well? Is the name the same? No, it's not. There are misspellings, a lot of stuff on that one. So we face basically broken identity. If we have unknown quality. Is it this well log or is it that well log that is valid? If you go back in time, well logs is printed on paper, and there are companies in this world that still have paper-based well logs. So of course, getting this in place is not an easy task, and the complexity of the data models, of course, are also large. So what we came up with was this. When we abstracted away things, that yes, okay, by using context diagrams from domain-driven design, you say that, okay, yes, we have the master data repository, which is responsible for identity, lineage, provenance or pedigree, basically. And we are able to exploit data type storage, if it should be a relational or a document store or a data lake or a file system. It can be tailored to the actual data type. The APIs, the service API, is then standardized by the industry. And of course, we are able to offload the applications, all the data management burden that they have today. And what we think then is that this enables what we called dataless applications and services, which we think might be a very, very good thing. If those contexts, who basically is in this just drawn here as exploration or in production, that uses some of the data types, but they don't have any sort of responsibility for the life cycle management of those data types they use. They read them and then write them back when they have done their job. So that's the pattern, and we think also that this pattern might be applicable to other industries like healthcare and automotive or anything. It's not bound by oil. And the dataless applications, I think, is basically two things to say about them. One thing is that they have no responsibility with respect to data. And if they contain internal data stores, that is for tactical reasons, typically to boost performance. And they basically use the APIs of the platform to get access to the data they need and to basically write results back. And results are treated as immutable data objects. So we don't change things. We just say, okay, here's a new copy of an interpretation or whatever we talk about. And of course that the platform then provides three types of API. It's search, find matching data sets. Then basically it's the read, give me a copy of a data set. And then when I've done my job, done my updates, I can re-ingest things back into the data platform, and it's then taken care of and made available and the graph is updated. And we think that this might have rather disruptive effects on the software landscape we have. Of course, but this is, say, we have also vendors and internal systems that basically are built like integrated applications. Large systems. It evolved over probably 10, 15 years of time. architected around typically a relational database. And of course, for some companies, those applications are their cash cows. And now we say we want to, okay, goodbye. We want to slice and dice, and of course, and bring the functionality we need from the old world to the new world. And also probably that these legacy applications, say 80% of the functionality is not used anymore, or was developed for making say one specific use case long time ago. So how to basically, I think that we will also do it with distill the functionality to go back to basically where we came from, what is needed now. But there is by no means easy to make such diagram, but this is not a simple journey. It's painful, and it's painful both for those companies who have, of course, who loses their cash cows, and it's also difficult for us who have all the data and the management of the application landscapes. So, and this takes me to what we call the Microservices 2.0 question mark, because what is and some thoughts. And here's an interesting one. This diagram, this figure, comes from a Dutch retailer in 2000. They had a service architecture they called the Delta. And the principles that was put in place for that architecture was basically what you find there. It's event-driven, it's asynchronous, it should be plug and play, flow-oriented, distribution, usage of, all that stuff, which was, this sounded brilliant. In the end, what we ended up with was roughly, I think there was roughly 15 business services, and which each of them being integrated applications with data replication between them. So, okay, you had, instead of having one beast, you have 15. And of course that is, and I think that's some of the lessons learned compared also to microservices. They easily evolve into something not that micro anymore. And the tooling we had doing this was the WebSphere, the Oracle database, a workflow engine from Versata, and the web methods integration mechanisms. I guess some of those companies are all gone, at least. So, yes, services has been there for quite a long time. Good conceptual thinking has been with us for a long time. Implementation has been very, very difficult. And of course, if you look at the definition, I would say one of the definitions of a microservice, of course, is it's something that is intended to be independent and easy and manageable. And of course, sometimes you end up with not one integrated application, but you get a distributed set of integrated applications. And of course, that is not, that might not be that easy to manage at all. So there are some really caveats related to those apps. So in that landscape, we thought that, okay, if we make, and this is basically the novel thinking that came out of this word, okay, if you think that, okay, microservices should be dataless, and of course they are, as they do today, they support business capabilities, they are focused on the work that is to be performed, leave out everything that has to do with the data identity and lineage. And okay, what does that mean? That they really become more like a mobile app with respect to how lightweight they are versus growing into the old type of software. So that was basically, of course, and then you can use domain models, focus on and of course, basically a data access service means accessing the repository using basically simple access methods like search, read, write for the actual data types. Think that could simplify things. And we also thought about, say, a diversion, but say agents as defined by, in this textbook, which I think is one of the seminal books on AI, of course, programs that solve problems. We have this model of, say, an agent that observes an environment and then, based on its internal rules, do actions against that environment. That is also a good architectural model. And if we think about microservices in this context, or as more like agents, that okay, they look at the environment is basically the data platform, the platform services, the data. And then you can sense the data, and then you do things that changes them. So the key thing is that the conceptual model could be more like thinking along the lines of agents. If that's a good idea, a bad idea, don't know, but at least it's something of these sort of, say, novel thinking around software service design. And of course, still, they are hammered out from what should be bounded contexts. And of course, they encapsulate what you would like to use, if it's be AI or machine learning or whatever type of technology you want to put in place. But the architectural, conceptual model is the same. And if you think about into the future, we can build structures like this one. This is, by the way, described in the paper we did in 2006 at the Uppsala conference. It's searchable. If you search about Uppsala and my name, you will find it. It's where we built that sort of experience, then not using microservices, but stacking context diagrams in from domain-driven design, doing strategic design. And I thought that, okay, yes, there's a lot of good thinking, but then it's been abandoned for many reasons. But going back to say, okay, maybe we should revoke these things, and also using the component and connector views from the documenting software architecture book. And of course, you can organize any of those patterns, basically, are applicable. Of course, depends on your application. So that was the last thing in this. So if we're going to summarize, of course, OSDU is basically an old industry-led initiatives where some of the world's largest companies decided, okay, we need to liberate our data from the application silos. We involved the open group to help us do the standardization work and make sure that the standard is open. And we also engaged the major cloud providers to help us with the implementation. And the first demo will go live in then June 6th, where we have use cases using machine learning, and we have more use cases using more traditional approaches. And the key thing is that, okay, we think it's a good idea to separate data management from application. And by that, we are able to create data-less applications. We get help simplify the data gravity problem, and we solve the identity and lineage. And of course, it will probably give us, and we see the contours of that, this give us more flexible and adaptable software architectures, where we can create more lightweight but also intelligent services, and where the services can focus on work, not on fighting with the data, which and the persistence challenge and data management challenges that comes from it. So we think that this will be a journey of both fun and pain. There is no, it's not, we see there's a lot of fun involved. Same time, we know there are hardships to come. So with that, I think I would say just thank you. If there are